TAs to add comments as well. Okay. Add a comment. All right, let's get started. It's 3 o'clock. I know. People have to come from other classes. So we have a very exciting day. 15 presentations, okay? And 15 next Monday, and then there are people who did not manage to sign up. We will probably have to get them to send us videos. So let's start with the first one. We are gonna keep you guys on time. Everybody has 4 minutes. 3 minutes for speaking, 1 minute for question, and Adam will keep you honest. 2.5 minutes, you get warning. Okay, so let's start. The first one is a video, right? So we just play because there are.
We call it a truth sleuth AI. So the problem we are trying to tackle is the misinformation on YouTube. And everyone knows there's a lot of false and misleading content online. It's really easy to create a deceptive video than to actually verify it. And fact checking is not really easy. It takes time, skills, and access to the reliable sources. And the studies have shown a better approach is to actually proactively fact checking the content instead of just removing it. And an approach like that would actually also foster balanced discussion while making sure freedom of expression is maintained. So, what we would like to present is Truth Sleuth AI, a sort of a multimodal debunker agent. So, it will have four parts. The first part, the agent will analyze the video, audio, and comments for a holistic understanding of the video. And the second part will be extracting and verifying the key claims made in the video against reliable sources or perhaps even a user defined data corpus. The third aspect will be generating a balanced discussion to encourage critical thinking. And finally, is present all the information and the discussion in a user-friendly interface, perhaps as a some sort of a text or a report or a audio or a video. So the next part, how does it work? So we think we can do it in four different modules. The first module will be a video processing, which will leverage the YouTube API and the speech to text model from Google. The second part will be extracting the claims. So we plan on using the LLM with the prompt engineering. The third part will be fact checking the claims extracted in this step number two. And we are thinking of using the data commons and Google Fact Check API and perhaps some sort of feedback loop using LLM to cross validate the results. And the final part is actually we would like to generate a healthy discussion with the framework similar to Storm and and just generate the discussion or audio or video in a format that's desirable by the user for the user, and also perhaps even some sort of a plugin that will just show everything on the side. So that's all I have. Thanks for everyone's time, and we would love to get some sort of feedback on our approach and about the idea, originality of the idea. Thank you.
And we're designing cognitive agents for kids. So we're going to walk you through existing work that is. Oh, is this turned? Hello? Hello? Okay. So we're going to walk you through existing work, existing research, and then the challenges that come with the existing research, and then talk through our approach and also some future work that we're considering. So we've been looking at programmed agents that can facilitate learning and creativity and self-expression in kids. There are things like robots that interact with kids, and like researchers have observed these interactions. And then there's also these agent-based like programming interfaces that like teach kids like computational thinking. There's also voice-based systems that teach kids computational thinking as well. And we found that there are some key areas of improvements from these agents, and one is tone. We found that we could improve the tone at which like the agents talk and interact with kids to make it more friendly. It could also promote communication for kids that are that have less like expressive characteristics, and they can do this by probing questions. And there's also an area to increase engagement through resources before these interactions, resources after, to enhance like learning activities and enhance like the whole process. So we want to aim to build this by not just an LLM input and output, and also not just a language agent, but a cognitive language agent which is inspired by the koala research that involves a memory architecture for retrieval and learning of like experiences and episodic memories that the agents have with kids, and then going through this kind of like reasoning process to provide like hypotheses about characteristics about these kids and interact better with individual kids in their environment. So yeah, our key question is how can we build cognitive architecture that enables agents to effectively learn about and also engage with kids?
Yeah, and as briefly mentioned, we aim to tackle this question by drawing a lot of inspiration from this cognitive architecture framework presented by a group of researchers at Princeton. And I think they do a good job at neatly capturing a lot of the existing ideas about agent design out there. And as you can see, there are lots of modules and components like memory, reasoning, learning. And what these authors encourage us to do is to view agent design in a more modular way. And depending on the application and domain we want our agents to be in, we can tweak and design each component accordingly. And for us, we want to design such a architecture for kids. So to zoom in a bit more, we hope to be implementing memory architectures such as the episodic memory to store history of interactions. And in the semantic memory space, we want to dedicate space specifically for the kids profile about like interests, personality traits, learning styles, etc. And for cognitive processes, we hope to design internal actions like retrieval and learning, where we infer new understandings about the kid and use this to reason about external actions and how the agent will actually interact with the world and kid. And we foresee a lot of downstream applications. Designers and developers could use such a cognitive architecture to develop interactive learning games, agent-based programming interface, collaborative family games, or interfaces to guide reflection, goal setting, storytelling, etc. And our expected demo would be an agent-driven conversational system powered by our cognitive architecture designed to learn about a child's personality and interests. And for evaluation, we draw a lot of inspiration from Jun-Sung Park's very famous generative agents paper, where we will run an ablation study to compare the performances between the agent with the full architecture or the agent without like the kid profile or without the learning process, and finally a human author as like a baseline or point of reference as well. And we'll just interview these different agents and configurations to see which one performs best, ask human evaluators to rank the quality and calculate like a true skill rating for these.
Yeah, so as for future work, we plan to look at everything else that is not semantic and episodic memory related. This includes also unintended consequences in the more like external actions area where people will be using this architecture to create interfaces that actually interact with kids. So these like interactions definitely with generative, yeah. Okay, thank you.
I don't think we have time for questions for this presentation, but just for like future presenters, I'll just give like a 3-0, just in terms of like you have 30 seconds left. So just make sure to look at me if you're running low on time. I'll make a sound, yeah. I'll just like scream.
Okay, great. Hello. My name is Elizabeth Holm. My partner Dylan Dipasupal has a last-minute interview, so he couldn't make it. But we are going to be working on Loqui, which simulates difficult conversations. The key questions that we have are how can we provide reliable, accessible information that helps people build and maintain healthy relationships? On a bigger scale, on a smaller scale, can an emotionally responsive AI chatbot simulate tough conversations to promote emotional resilience and relationship building? Now, our motivation for this is that a lot of people struggle with initiating and carrying through difficult interpersonal conversations, which includes, resolving conflict, setting boundaries, or even giving feedback at work. And access to therapy is limited, especially for marginalized communities. So we are aiming to develop a chatbot that simulates these conversations with different emotional tones and allows the users to practice in a safe and affordable space before taking those skills into the real world. And our goal is to help users improve their confidence and interpersonal skills. As a quick overview, Loqui is going to mimic human conversations and emotional responses to help users practice difficult conversations, such as setting boundaries and conflict resolution. As an overview on how the users will experience this, first they will specify a tone for the bot, such as empathetic, assertive, neutral, or defensive, or also a random tone, which can help them prepare for anything. And then they will have a simulated conversation going back and forth. And at the end, they will get a feedback report on what they did well and what they could improve on when they have this real life conversation. For a little bit of a technical overview, for the tone simulation, we're going to be using prompt engineering for the LLM to simulate specific tones, such as empathetic or assertive, ones I mentioned before. For the user inputs, we're going to limit things down to preset options so that we can test those and make sure that this, it's a seamless user experience with a more controlled setting there. And then the chatbot will hopefully engage in realistic dialogue based off of those preferences that they set. On the Genie worksheet side of things, the LLM is going to evaluate user responses, like each utterance that they say, based off of a few metrics that we're going to define. A few that we have in mind are safe space, emotional charge, and like the acknowledgement of what the bot is saying. And then it'll be scored from 1 to 5 on those various categories, and at the end it'll summarize all of the scores and give suggestions based off of that scoring system. And the way that we're going to test our bot is weekly user testing in a more casual sense, just seeing how they're interacting with it and making it a more seamless use. And then, comparing the feedback that that the chatbot is getting with professional therapy advice for accuracy. And then more towards the end, we will evaluate the chatbot performance with user ratings, based off of a few different, essentially a survey that we'll send them. How natural was the tone? How good was the feedback, etc. And here we have a quick timeline of how we're going to do it. This week, we're going to finalize a few of the implementation details. Week 5, we want to implement the initial conversation flows. Week 6, implement the end of conversation report. And then week 7 through 10, have user testing and iterate on our design. And if time, incorporate some sort of UI. Our end goal is to help users with having difficult conversations in the real world by simulating them through a chatbot in a safe and low-cost environment. Thank you.
Hello, everybody. We want to help policymakers create better policies by pegging into the evidence of previous empirical research on what works in policy. So bad policies are created by these causes, right? We have corrupt politicians, ineffective institutions, but something that we can do, minimum we can do, is helping policymakers overcome cognitive biases, in other words, knowing what works and what doesn't, and if we can provide that to policymakers in a structured way, we believe that policies can be more effective at solving global problems. This is not something new. This has already 4 decades of people here in Stanford and other universities studying estimators, statistical estimators, and doing research on what works and what doesn't in policy. And what we want to do is essentially, like our 2 research questions that enlight our solution is, first of all, we want an agent that is able to interpret econometrics, that is able to analyze tables. Econometrics, for those who don't know anything about it, is the combination between economics and statistics, and is super helpful to analyze when a policy, a social policy, is useful or not. More importantly, we want to know how to scale the success of a policy that works in a country that has data, and we want to tell the policymaker, hey, you can learn from this case, and this is the key things that you need to have into account.
Okay, so what motivated these research questions is that the process of grounding evidence-based policies is very complex, it's time-consuming, and it's sometimes done by governments that don't have like enough resources, time, etc. So the solution we propose is a policy agent that is able to execute 3 main capabilities. The first one is that, as David was saying, interpret economic results, which are like complex by nature. The second one is identify and highlight what are the conditions, because all of this is in the context of experiments, so the results are very tied to the conditions of these experiments, and it's like of key importance that the agent is able to identify that relationship. And finally, it's able to generate some advice, and the advice is in the form of like, how can we scale successful policies? How can we identify the risks in these policies? And how can we suggest some partners from previous policies? So if we jump into a more concrete expected output of how the agent will work, the first interaction would be how, like, the policymaker says, I want to do a policy for my county that foster inclusion. So the agent here will start like prompting the user to get more details, as we were doing, for example, in homework 2 with like the hotel booking reservation. And it's like, okay, in which field? Do you have any target population, etc.? And once we have like all the detailed information, the agent will go and retrieve relevant papers for this policy. After that, we want to emulate co-storm in the sense of like the user participating in a discussion with experts. And finally, the output will not be like a Wikipedia-like article, but it will be a memo, which is like a pretty standard document in this context. So yeah, that's the expected output. And yeah, thank you so much. If you have any questions.
Thank you. Since I used to be an econometrician, theoretically, so I have a couple of questions. First of all, I think this is a very great idea for, developing this kind of, agent for policymaker. However, as we know, right, in the real world, lots of policymaker, they don't encounter any specific economic situation. And also for lots of, economic policy, they don't have any optimal solution. Let's say for the monetary policy, right? In some sense, they can help, the growth of the economy, right? However, it will pay for the cost of the hyperinflation to some extent. How will you guys mitigate or make a trade-off between this kind of policy? Because there's not always have a better solution. Secondly, for those, like, counterfactual, economic situation, as you mentioned earlier, right, you can do some quasi experiment. However, for some countries, their policy is not always applied for, the other country, right? Because different countries, they have different, situation. Have you thought about that? Yep.
Yeah, both great points. Definitely in evidence, there is no, evidence contradicts itself, right? So what we want to do is to give a nuanced perspective to the policymaker. This is what for example, this is what most of the research tells you that this policy works or not. That's something that we think is useful to the policymaker. And also tell to the policymaker, hey, in these cases, out of 10 studies, the policy didn't work. On the other case, you're right, scaling policy is super challenging, right? So, but we want to point out to the policymaker what were the factors that were behind the success of certain policy in a country. Thank you so much.
So hello everyone. Our project is going to be a little bit different. So instead of building AI agents, we're going to be focusing on studying whether or not we can reliably monitor the skill acquisitions of these agents as they get stronger and stronger. So a while ago, OpenAI published this paper with too strong generalization, which asks the questions, can we reliably supervise these AI intelligence as they become stronger and potentially eventually passing human levels of intelligence. And so in today's world, the human experts are the teachers and the AI models are the students. They can, in some tasks, outperform an average level human being, but they're still not reaching the levels of human experts. However, in the future, they may get so much more powerful, such that we now face the problem that can we still supervise these agents as they become as they're getting beyond our level of intelligence. So in their analogy, we're using kind of weaker models to supervise stronger models to stimulate and study this behavior of super alignment. And so in our vision, the current world, like all the skills, domain knowledge, and cognitive capabilities are explicitly taught and elicited by human beings through, say, fine-tuning, prompting, grounding, tool callings, etc. But in the possible futures, these agents may learn to autonomously acquire new skills and capabilities through interacting with the environment themselves. And the question we want to ask is that can we reliably detect and monitor the capability and skill acquisitions of potentially superhuman AI intelligence? And it is important not only because we want to better understand and interpret these AI models, but more so, we would like to detect early warning signs of potential harmful behaviors and capabilities. So formally, we frame our research problem as follows. Can weaker AI models effectively detect and characterize the acquisitions of new capabilities by stronger AI agents in a dynamic interaction setting? And specifically, we would like to target, can weaker models identify that stronger agents have acquired new capabilities? Can weaker models determine when during the interaction does these capabilities occur? Are these capabilities acquired? And finally, given varying levels of prior information, to what extent can weaker models accurately characterize the newly acquired capabilities? And for our preliminary experimental framework, Claire is going to describe.
Yeah, to answer those questions, we ground our experiment in the agent negotiation task, specifically the multi-issue bargaining task. In this task settings, two agents are going to negotiate a split of items between them. Each agent have different valuation for the items, and the goal for them is to maximize their own utility. To simulate the acquired capabilities, we allow a few tool or function callings to be used for the agent. These acquired capabilities include non-cognitive ones and cognitive ones, which we will discuss more in detail later. But for non-cognitive ones, it refers to the ability to interact with the meta negotiation environment.
And the cognitive capabilities refers to knowledge acquisition, reasoning, memory, etc. To get a better idea of a more concrete scenario, we will have a few items on the table. For example, orange, apple, and banana. For a vanilla agent, it might think that, it values the apple the most, so it's going to get the apple first and then split the rest. However, for a skill-augmented agent, it might realize that there is a function call called add item, which can add more apples to the table. So it will take advantage of this function and then proceed with 11 apples on the table.
So just to clarify, the function calling the capabilities we're simulating here is by manipulating the game environment by changing the available resources on the table. So in this case, we only have one apple on the table, and the agents are usually, just negotiating on oranges and bananas. But if the agent has the capability to alter the game environment and actually add more apples to it, it can hugely maximize its own goal without having having the previous kind of quandaries that the agents were having.
So we also have a list of relevant capabilities for this multi-issue bargaining negotiation. For non-cognitive skills, it includes adding and removing items, bundling items, transform each agent's values, and imposing a time constraint on its opposing agent. And for cognitive ones, it usually includes reasoning, which is whether the agent can draw parallels from other knowledge domains, like empathy simulation, followed by a strategic planning based on the other agent's perception of the items, social behaviors, and other types of meta learning. And to test whether a weaker model could monitor such emerging capabilities, we have two major experimental setups. The first one is that we will give the monitor model two negotiation logs. The first one will be between two base agents, and the second one will include an agent with these acquired new capabilities. And then we will ask the monitor model two types of questions. The first one is that we will give the previous list of capabilities to the model and ask whether the model could recognize which agent is a strong agent, and among the list of capabilities, which capability the stronger agent is acquiring. And the second one is that without the list, can the model accurately recognize these capabilities and the stronger agent? And the second experiment setup is that if the capability emerges in the middle of the negotiation process, can the weaker model identify at which point of time the agent has emerged new capabilities?
So we've already experimented. There's some very preliminary experiments. Yeah. Okay. Yeah.
Sorry.
So this is just.
So we can give you feedback offline.
Okay.
Okay.
Cool.
Thank you.
Hello, I'm Jay. I'm Sina. Cool. So we're planning to build Fine Dine, which is basically a platform to help people navigate dietary restrictions. So this is a problem that's growing in the US. Over 60% of households have a dietary restrictions, and this has gone up every year since 2007. And despite the fact that this is a growing issue that's gotten a lot more complex, there's still kind of a really big lack of resources to help navigate them. And so as someone with a lot of dietary restrictions, this is a problem that I encounter a lot, but oftentimes the current process is basically just like a lot of online searches to look through different restaurants, like go through each of their menus to find compatible options. And then on top of that, oftentimes like calling restaurants to ask about like cross-contamination or like detailed questions that might be hard to find on the menu. And I guess this was an area where we thought we saw a lot of potential improvement in kind of automation.
And so this is all specifically when you're going out to eat to find a restaurant, but yeah, our plan implementation is a conversational interface, kind of like the what we've already seen in class, to gather the user's preferences and dietary restrictions, and then go through restaurant and dish information to find compatible restaurants and specific dishes from those restaurants that work with the user's needs. And then something that happens a lot is, especially if you have restrictive dietary like needs, you have to call in the restaurant to make sure that it's prepared a certain way, or there's a dish you can have if they can like make some kind of substitution. And so it's a very quick phone call, but it's like annoying having to make like 6 of them to figure out who can do it. And so that's something that we're hoping to do, to gather what the user needs and then automate a phone call to make sure that that's something that can or can't be satisfied at the restaurant. So the way we were planning on doing that is for gathering the restaurant and dish information, either gathering it ahead of time by like scraping, or using Yelp and Google Maps to gather it on the fly for things like which restaurants are near you. And then for automating the phone call, we were planning on using the real-time API. Yeah, and then the last thing we want to ask is if anybody has dietary restrictions, shoot us a text, because we'd love to see if it's useful for you and how you do it. Yeah, thank you.
I think there are a lot of people typing into the document, and it is not possible sometimes to put it in. I recommend that you put it in a different file, and then we can add it at the end of this meeting. Okay. If you're having problems with the Wi-Fi.
I think we can call it next group and questions. Time for questions, no? We can take it.
We have like one question.
Yeah, if there's one person.
Anybody got a question?
Hello. Our project is called Easily Legal. I'm Peter, and this is Jordan. So our key question is that, well, we're looking at like existing models like ChatGPT, Claude, and Gemini. They often pose challenges for like non-native speakers, especially like Spanish speakers, like immigrant type demographics, especially in like legal contexts, like contracts, small claims court cases, stuff like that. We try to use ChatGPT to like, we've used ChatGPT multiple times to sort of help translate docs that are in Spanish, like legal docs in Spanish, to English. And a problem we keep like that keeps occurring for these current models is that they maintain a lot of the jargon, and they sort of, even when we ask to simplify to sort of like colloquial terms, it doesn't speak like an actual person. It's like the translation that we often find is not like, no one really speaks like that, and it's super confusing even for like native Spanish speakers. So our question is, can we create a large language model tailored for legal doc readability and understanding? So our target audience is, Spanish speakers predominantly, immigrants who often, struggle to understand these legal documents. Currently, only 13.7% of the U.S. population speaks Spanish, and creates like a significant barrier for finding help when it comes to legal matters. Especially for us, like our background too, our parents would often ask us to, like, even when we were kids, to translate legal docs, and we try our best, but we're not pros. And even now, they still ask us to, and we can do a better job. But our parents shouldn't have to rely on constantly texting us, shooting us emails to translate documents. So our objective is to develop a practical, deployable tool that enables clear comprehension of legal documents for Spanish speakers of all levels. The data sources we're going to be using are just like legal doc databases, both in English and Spanish, like the Mexican Congress's like legal doc database, also for Peru, Bloomberg Law, and the Glenn Foundation, just for a bunch of legal docs. We're going to be using like current Spanish language translations of English documents and community-driven text. So our output could be more, real-world, colloquial, like short-form Spanish.
And yeah, as far as like kind of a technical approach, we plan to use a lot of translation APIs, as well as like pre-trained models, and try and focus on like fine-tuning them, as well as like gathering more just like common common focus for like loans, house loans, and immigrations, and for metrics, just kind of some basic ones like a lot of people know, just like blue scores to see like how accurate it is like a translation, and rogue in order to see like how well it is a summarization, as well as the flesh Kincaid in order to see how well it's able to summarize and simplify certain legal matters.
And finally, our deployment would be we'd want to create like an app, sort of like a chatbot, but that is scannable and where you can upload legal docs and get like real time translations, and like you can ask questions, when you need like comprehensive understanding of a legal document in real time. Question?
Hey, I'm Ben.
I'm Ollie.
And we're presenting on our project idea, which is a multimodal virtual art docent. So as part of the motivation for this project, we believe that docents are like a super essential part of the art museum exhibit experience because, as indicated in this image, it really allows you to actively engage with the work, have both your physical connection to the art in person, but also a connection with a person that you can ask questions, so you can get the narrative of the art historical context, and then also dive into the actual visual, physical, and aesthetic elements. But in recent years, a bunch of art museums have really been struggling with retaining docents and volunteer workforces in general, especially with COVID. And a bunch of major museums have even canceled their art docent programs, which were long essential aspects of their overall program. And that includes like the Chicago Art Institute, for example, which is like one of the biggest museums in the world. There are also only 9% of US high schools that have AP art history programs. And a lot of those are concentrated in affluent areas. But a lot of people still have access to museums, but not people that they can interact with at those museums to get this personal connection to the art. We've also seen throughout different psych literature that visits to art museums demonstrably improve psychological well-being for visitors. So we wanted to see if there was a way for us to leverage this LLM technology to promote a really accessible interactive experience with artwork in person. So we originally just wanted to see what ChatGPT and Gemini and Google Lens could do about this problem, but we ran into all sorts of different problems with each of these systems. ChatGPT was just hallucinating about basic facts constantly, had a really surface level analysis, although with really common works, it was actually pretty good at identifying things via the VLM. And it often would include kind of long tail, irrelevant, that's supposed to be irrelevant, not relevant, irrelevant information. While Gemini would kind of take the other approach where it'd be really conservative about not wanting to hallucinate. So it just would like basically include no useful information in its response and just ask you to provide it yourself. Then Google Lens basically just works as pure image retrieval. So there's not really this interactive and analytic component we really want to instill. So yeah, just as a super quick example, this is kind of like canonical with what we found with ChatGPT, but it's super confident about what the name of this painting is, who it's by, when it's from, and the art style it's in. And literally all 4 of these are wrong. But all of this data is in this cool corpus we found. By the way, that's the artist that it thought it was. It looks totally different from this. We found a great corpus called WikiArt that this is an example from, that has all this data on different art pieces, including the actual facts. So we want to start by grounding our responses in that.
Yeah, so essentially the goal or vision for our project is to build an app where someone can take a picture of an artwork or painting, and the model will output specific facts, quick facts about the model, about the painting. And what we don't want is for the model to just output a ton of long information that is not relevant. And so we want to do a ton of prompt optimization. And we also want to explore how well the agentic framework we've been learning about in this class can generalize to multimodal input. So there's this really cool recent paper, Cole Poly, I would highly recommend checking it out, that basically uses VLMs for retrieval. And so what we want to do is kind of apply that framework in this setting. And here's kind of our proposed potential workflow where we do kind of a multi-step information retrieval before doing the multimodal analysis. And we really want to focus on grounding our work and also using alignment with LLMs and VLMs as a judge to make sure that our response is refined and grounded in the actual visual information that the user gave as input. So yeah, any questions?
Cool.
Thank you.
Hello, everyone. I'm Aditri, and this is Advit, and our project is called Goodnight GPT around generating personalized educational stories for children. So main questions that motivated us were, can we generate engaging stories for children, collect their preference data through a series of a few short interactions, and then work towards a children's data set, because we haven't really been able to find a children's preference data set so far.
So as a motivating example, a lot of the conversational virtual assistants we look at today are text-based, but there's so much more you can do with text. So here's an example from Geronimo Stilton. It's the exact same text, but if you add things like fonts, different colors, bold, italics, and just small images here and there, it makes the text a lot more engaging, especially for younger audiences, and especially if you want the content to be more educational. So as an additional example, I think this is Cat in the Hat. Very simple thing where it's just adding an image and then just playing around with where the text is placed can make the whole experience a lot more engaging. For us, it may not matter as much because we're a lot older, but for younger audiences, it can play a key role. And some of our motivations behind doing this are just the increase in homeschooling, where in the past 6 years, partly due to the pandemic, it's increased by a lot. And because of that, there's no personalized systems for learning about topics meant for younger audiences. So we're trying to build something. We looked at one example and it wasn't that good. Additionally, immersion, where currently all the virtual assistants are just text-based or some have images, but there's so much more you can do to make the experience a lot better. And then finally, just preferences, where there's no child preference data set, because most of these volunteers for RLHF are 18 plus. So maybe building towards that as well.
Just to talk a little bit about the methods, we're planning to gather a few preferences through a chat-based interface. So we'll enable the ability to provide a topic that the user wants to learn about, a few reference samples and styles that might be engaging to them. So we could ask, for instance, do you like text in this style or another style like roll doll versus like cat in the hat? And then we'll use text style unbundling to try to understand the key features of that text and then apply it to generate our story.
And then once we have the story, we can apply those processing for the format. We can use that to identify where are the most impactful places to put images, generate consistent images, and finally put it all together nicely into a click-through animation UI, along with potential voice narration, letting parents or users put their own voices. And then we'll breeze through the methods real quick. So we looked at some works on style-to-style transfer, so we'll do that. We'll identify key things from the references and inject that into our generated context. Yeah, we can just go through.
And then image consistency is pretty challenging, but there have been a lot of recent works that try to use only prompting to generate long-form consistent images across 8 to 10, across a set of 8 to 10 images. So we'll play around with that prompt engineering piece too. And then for evaluation, we'll collect pairwise preferences through our UI, and also try to evaluate image consistency using LLM as a judge, and trying to see if the key entities represented in the story are represented in the images as well. Thank you.
So hi everyone, my name is Jen and this is Jason. And our project is called Personalized LLM Room Designer. So the motivation. So people nowadays need to hire professionals to design their house or their room, which takes a lot of time and money. And some people, they just prefer not to leave their home design entirely to some other people, or they actually have some general idea, but just don't know how to execute it. So this means that people really want personalized agent to help them with such design. And thanks to LLM, we can now build such agent. So the key questions, first, can we build such an agent using the power of LLM? And second, can we let the user to actively participate in this design process so that they can provide feedbacks at any time? So a simple example, so the user might say, okay, now I want to design a bedroom, and the agent will say, okay, here's a bedroom, and the user can provide some feedback like, oh, I don't want a desk or a chair in the bedroom, or I want it to be more old-fashioned. So the agent will adjust their output according to the feedback, and in the end, generate some design that the user are satisfied with.
Yeah, so we've reviewed some of the related works, and these are some of the common issues of those works. So a lot of papers, they cannot directly revise the design from user feedback. So you ask for a design, and the model will generate something, and then it's pretty complicated if you want to move the window to the left a little bit or something like that. And then other features, other issues are a lot of papers only feature one agent, which is just the designer. So we think that it has very limited capabilities when designing the room. And then some earlier works have furniture overlaps and out of bound when try to place the furniture in the room. So our current plan is to use this existing framework, which builds the room from an empty room, and then you place all the basic equipments, and then you select all the furnitures, and then place the furnitures. And then we try to add these new features to allow multi-agent interaction. So we have multiple agents with different roles that will come up with a design together, and then we will add user feedback for each step so that users have more flexibility to control what rooms they will get. And then for evaluation, we probably will mainly get GPT-4 evaluation and very limited human evaluation. For quantitative evaluation, we have this out-of-boundary rates, which evaluates how likely is the furniture to get out of the room. Yep. And that's all.
Hi everyone, I'm Arjun, and this is my partner Ethan. And today we're going to talk to you about our project idea, which is a drug price negotiation bot. So to give some context, 1 in 3 U.S. adults on prescription drugs have unable to take this medication just because of how expensive it is. And this is a big issue for a really long time. And recently, with the Inflation Reduction Act, the Medicare and Medicaid services they're known as CMS, recently passed this law that allows them to basically negotiate drug prices to lower costs. But a big sort of issue with this process is it's very sort of labor intensive and time intensive to actually identify which drugs to negotiate for, because there's a lot of sort of extensive criteria in terms of how much Medicare is spent on it, in terms of the impact on public health in the US. And so we want to basically leverage LLMs to see, can we streamline this process of identifying and analyzing candidate drugs for figuring out which ones Medicare should negotiate.
Yeah, and for a high-level criteria, what Medicare and Medicaid look for when it comes to potential drugs for negotiation are like high spending, where Medicare and Medicaid spending a lot per state, where is the usage high. For those candidate drugs where spending is high, usage is high, and prices have potentially been increased, is there market competition that could actually lower the prices naturally? And then once you figured that out, how long have they been in market? Because you still want to maintain incentives for pharmaceutical producers to kind of bring these drugs into market. And then finally, are these conditions like very serious, relevant, and kind of standard with health trends in the US? And we have corresponding data for each of these areas, and we think that this structured approach lends itself to kind of a Genie worksheet based kind of task agent that helps walk a policymaker through identifying what could be a good drug to negotiate prices on.
Yeah, and so to give you some more insight into what the process looks like, as Ethan mentioned, there's sort of these different sort of criteria that goes into determining which drugs should be negotiated on. So, for example, looking at spending, so Medicare, there's historical data on Medicare spending and how much they've spent on these drugs historically, and so looking at that. Also looking at sort of trends in the price as well. Is there sort of drugs that have significantly increased in price over the last couple of years, and looking into that as well. And then also a big sort of specification is Medicare can't negotiate drugs, price on drugs that have sort of generics or have existing competition out there. And so looking at those drugs as well. And then finally looking at sort of like health trend insights and whether sort of what health outcomes will this drug have if we're able to sort of reduce its price, and what conditions does it treat.
Yeah, and for a brief walkthrough on methodology, this workflow is pretty simplified, and we're going to build it out. But you can imagine a Genie worksheet that kind of constrains the agent to draw from specific databases when queried with specific information regarding prices or spending, which have two different associated data sets. The Genie worksheet will also trigger Python code that allows us to analyze and kind of bring up like spending charts and graphs. And then one of the interesting components of this application, we think, is the ability to take in PDF documents like SEC filings, so you can build counter arguments from a manufacturer's perspective, and then kind of go back and forth and simulate a negotiation from Medicaid and Medicare side, and then the private company side to build out a policy brief in that regard. So yeah.
Thank you.
Hello. How's it going, everybody? My name is Carter. This is Jonathan, and we're building findyourpath.ai. So just a little bit about the motivation of this project. Specifically, career exploration during high school is often a critical motor for improving socioeconomic mobility, but the access to opportunities to do so remains unequally distributed. We pull some statistics on high school students around the US, where 40% report feeling unconfident about their chosen career post-high school. 72% report feeling rarely, often exposed to different career options, and 64% report having 5 or fewer conversations about careers with teachers or counselors. And so on top of that, traditional career guidance tools often fail to adapt to students' evolving interests, which further limits their ability to discover fulfilling paths. And personal mentors often drive solutions and actually offer significant improvements in career discovery, but unfortunately don't scale. A lot of students don't have access to one-on-one mentorship or specialized career counselors or college counselors to give them the advice to actually pursue career paths. And so it kind of begs the key question of our project: what if every high school student in the US had a personal career discovery mentor? And how do we align recommendations with a student's evolving interests, skills, and life achievements over time?
So our idea is to build a chatbot that can recommend personalized career paths by utilizing unstructured and structured data. So structured data would be kind of data sets we find online with job postings, survey data, and the unstructured would be student LinkedIn profiles, user input on the kinds of careers that they want to explore and the skills that they want to learn, et cetera. So the idea is to use a RAG model with a Siamese neural network to enable effective comparisons between student preferences and generating relevant career recommendations for them. And then, as Carter said, one key thing that we want to implement in the system is the ability for it to be adaptive and change according to user preferences, because career, especially for students, career interests change so much over time, and also the career landscape changes quite a bit over time as well. So the idea is, I touched a little bit on data sources, so I'll skip over this. After some basic pre-processing, the system would basically be a RAG model, so it searches for relevant career paths, matching student profiles, and generate suggestions. The Siamese neural network would be used to map these student profiles to the most relevant paths according to, by comparing and generating similarities between their preferences and career data. And then we would also utilize reinforcement learning to adapt recommendations based on how students feel the chatbot is performing, and also if their preferences change longer term. So this is an example of like a basic Kaggle data set that we found on LinkedIn job postings with descriptions, desired skill sets. This would be an example of some of the unstructured data that we would use. So asking questions, like the kind of skills that you want to develop at work, the kind of work culture that you would excel in, and also like the core values that you seek to find. This is like a very high level, just first stab idea of the architecture. So two different types of data in a knowledge base, combining it in a shared latent space with the Siamese neural network, and then adding that to the RAG model, and then the reinforcement learning from the user after the initial recommendation to sort of refine the system.
I guess really quickly going more into our system. So we derived this method from a paper talking about semantic textual similarity. So specifically, Siamese neural networks would be mapping sort of the career preferences with the grounded truth in the data on job postings and what skills are required for those careers. So we look to inject similar strategy. And then in terms of the RL of our system, we would be using a feedback loop where users can provide their preferences in the suggested career paths, basically rejecting or modifying the suggested options, and then rating the relevance of the recommendations. And in terms of sort of the result of that feedback, so the positive feedback would update the reward system, affecting the likelihood of similar recommendations for users with similar preferences. And then the negative feedback would update the penalty system. So reweighting certain features like de-emphasizing skills that the user doesn't like. And then lastly, our policy optimization, so updating how it selects career paths or new queries. And then lastly, we have a bit naive approach with evaluation, but expressing feedback, so determining precision on true positives, false positives. Similarly with recall, measuring how many relevant career paths there were. And then lastly, an F1 score to determine the balance in precision and recall. So that's essentially our system. That's all our slides. But yeah, any questions?
Once, maintain forever. It means that the system design and implementation is only the beginning. The day-to-day monitoring and maintenance will likely take up the majority of the software lifecycle. While trying to keep a software system healthy, a developer may care about the following. First, they might want to identify the cause of software failures. A common question to ask is, why did my service fail? And eventually, they want to find out which stage in the workflow has thrown what kind of exception that has caused the failure, and maybe also get a link to the breakpoint if possible. A lot of events, such as a new deployment, could happen automatically or overnight, and such events could easily be buried in a pile of log files. To further debug the system, they might also want to retrieve the runtime history and get to know what happened during a specific period of time. Finally, to fix the issue, the developer may want to request an action. A very common one would be to revert the software to an older version. Now we know the developer's task, but what do they have to work with? The answer is logs. Oftentimes, the only thing available to the developers is a huge bulk of log messages sent out by different services and submodules in the system. Unlike the errors from individual programs, such as the Python script, which usually contain helpful tracebacks to let you know which line, which file errored out, and why. The system logs can be much more complicated. One service may report an error or warning, and it affects another service, which throws another message, so on and so forth, until something fails. Also, the system log could span thousands and thousands of lines, which is not something you can simply copy and paste to ask ChatGPT about. Even for professionals with years of experience, sifting through these log files is still a pain. As software engineers ourselves, we would like to build something that makes monitoring and debugging software systems much easier. Luckily, the logs have some nice properties that make our help quite accessible. First, the logs are usually in a standard format defined by the platform, meaning that it's unlikely to improvise something that's confusing and unexpected. Second, the logs are usually verbose and informative enough for basic triaging tasks. Last but not least, the log texts are in natural language, which means that we can leverage the power of LLMs to handle them. Precisely, our idea is to build an information retriever to parse and extract information from logs, and a conversational agent to help the developer with their questions and requests. Here is a system overview. A Genie worksheet will be created for the interaction between the user and the LLM-based conversational agent. For information retrieval, we will experiment with 3 different solutions, including direct prompting, RAG, and text to SQL. That's all for our presentation. Thank you.
Presentations. Do we have Matteo and Nick here? Because I think the slides are not there, but their name is up there.
Yeah, we changed to another proposal.
Are there anybody else who are ready to present? Because we have several people looking for slots tomorrow, on Monday. Anybody? No. So maybe we need to squeeze a few more in the next class. So, are there any questions or discussions about the topics that have been presented? Because we wanted to keep to the schedule, and we actually have a few minutes now. Nope. So, yes.
I guess I'm like a very general thing, but that I think applies to most things. But I feel like one concern that I have about a lot of them is that it's targeting I'm not sure how like evaluations would happen in the sense that like it's the ideal user would be like I imagine like either kind of hard to get hold of in like a user study or like for example like I've noticed like I think there are multiple projects that were like about like hurting like children or like helping children, I feel like maybe sometimes the preferences of children are like not exactly what's good for them. So I wonder if there's like a little bit of consideration in terms of evaluation we had where there's like some other metric other than just what does the child prefer that is helpful.
I think that's a very concern. And I want to point out that for a lot of the projects that we were talking about, there is related work. And we don't, we have a 7-week schedule. And so we definitely want to encourage everybody to do the readings to find out what people have learned. And we will speculate to some extent. I mean, we will probably make some wrong choices as well because we will probably have to learn more as we go. So, but definitely try to do the research for the grounding of the material. I see that some of the talks have very good grounding. Here are the papers that have been presented. So I think that that's the main point. So the thing I want to emphasize, and I have comments, but I couldn't put it into the online sheet because of the traffic. I think it is not, you can't put them in, but we can all put them in at the end of the class. And what I think happens, what we heard today is that there are a lot of very, very well-motivated topics. And they are only doable just right now with the LLMs that we have. So I like the fact that they are very ambitious. They are kind of pushing the limit of what we can do. But I want to focus on the fact that you do have about 7 weeks. Okay? And you cannot finish a big project in 7 weeks, but you can put up a prototype of the key things that you want to test. Okay? You are saying that these are the things that we need to do, but here, so for example, if we heard about the room design, and then one of the topics is that the furniture is overlapping. So you have a choice. You can say, I'm going to ignore it for this paper or for this project. Or you can say, I just want to work on that piece. Okay, I'm much happier if you take a problem and you identify something that you have enough time for and try to dig into what is difficult about that topic, rather than put up something that kind of barely works for many, many different use cases or different case studies. I think that so that's what I would like to emphasize. I care more about the difficulties that you find out in the projects rather than say, oh, look, if I script my input properly, it will come to a good, it will work well. The minute you move away from your script, it doesn't work anymore. Okay, so that is not as interesting as something is like I try to do this and I discovered 3 problems. Now that is something that we want to hear. And then for each one, you just say, I have picked this one and I have gotten this far. And then one of the things that we want in the project report at the end is future work. What does it say about the future? Don't do this. I have tried it. Don't do this. Or here is really what we have discovered. Okay, so keep in mind, the whole problem is to understand the problem. Okay, and bring it down. And the first thing you want to do when you start your project is to just identify the easiest case and go into it rather than saying, oh, this is all the things I have to build. And you build horizontally all the pieces. And I say, now I'm ready to do the next step. It's like, don't do that. Okay, I have seen so many projects in the past, in other projects, and not in this class necessarily, but where they say, oh, I need all these pieces, and they keep building all the infrastructure. And I say, oh, I run out of time. And then by the time you actually, if you don't run out of time, you start working on it, say, oh, that infrastructure is not what I need. I can't use it anyway because I'm stuck here. So in research, you want to go depth first. You really want to stick, it's like, I think the biggest problem is this. Go work on it first. Okay, you create your harness, get to the point, and says, suppose I have finished doing this. This is the part that I'm worried about. Try it out. That's what you need to do. Okay, and then you can I think some of these projects that I have heard, you will be simplifying the project. You'll be doing a section of that project, okay? And so this is a standard, so we will help you through this process. But make sure that you try something out first, because with LLMs, you can quickly get to one round, something, and to say, oh, this is not helpful. Another comment is that we have presented two infrastructures. There is Storm, and then there is Genie worksheet. And what I heard today, there are a couple of projects that are actually neither here nor there. They're kind of a mixture of these things. So we are actually creating another framework that helps you analyze information in your study. Okay, so for example, Storm has is just doing search on free text. It actually doesn't bring in data from tables, which you need. And so some people were talking about using the worksheet framework because we have databases there. But we actually are putting together so you can actually do the same thing more at the investigation level with Storm, bringing those two pieces in. So we will try to make that available, that's the kind of discussion that we will have in the next week or so about how we go about doing these things. Okay. Any other things that we should discuss here? Yes.
Logistical level, how do we find a mentor? And should we just reach out, or is that going to be later?
Good question. So we are only seeing a fraction of the projects because a lot of projects were derived or part of the projects that have been presented. For people who are proposing the projects, we will give you a mentor. Okay, it will be one of the TAs from the class. And we will look at it and we'll do a match. And so everybody will have a mentor, for sure. Okay, regardless of whether it is something we proposed or something that you propose. Okay, and and what we're going to do, we will explain this in more details, but every week you will be writing down you will have a weekly report on what happens last week, and you will have a meeting with a mentor every week. So they will be helping you with whether you have questions or whether they see that you are stuck or whether they see what you're doing and say, maybe we should try something else. So you will have somebody to talk to. So roughly the way it's going to work is that you get to talk to the TAs, and I'll talk to all the TAs. And I will be actually monitoring all the projects through the TAs because there are just too many projects. I cannot talk to everyone personally, but we will be doing the discussion, so I'll be aware of what everybody is doing also. And we will try to give you the help as you go. And the hardest part really is formulating the problem, by the way, okay? Because we're not trying to build a product in 7 weeks, and the projects are not exactly like fully, it's not all complete for sure. So we have to kind of navigate to make the most out of the time we have. What is really neat that we have found is that because you have a time limit, a lot of times you actually get to the issues faster because you are building the first prototype. You can, get by without doing all the pieces that you will need in the product, but by doing so, getting a first prototype up, you can actually learn faster. Okay, so this is so don't feel bad to say, oh, I want to do this, but I can't. The whole point really is to put a time limit on it. You do the exploration, and you will probably learn the most for in that period. And then at some point you say, okay, this is what I want to do, and you can take the time to build it out. Okay. Any other questions? Nope. So if that is the case, then we will just meet everybody on Monday. And, I see that there is maybe 50% of the class here. And I just want to restate what we said at the beginning is that we really expect people to come to class, and we will make a post about that. And clearly, we know who are coming to class, and we have already discussed the fact that there is a percentage of the grade that is allocated to the class participation. And clearly, we can see who is giving the feedback to the class, because we all benefit from trying to come up with the feedback and also listening to other people's feedback. And that is the kind of participation that we have been, expecting. Okay? All right, I'll see you on Monday.